Okay, let's start the discussion. So let me take those questions. Few questions are there. Then we will be moving to this topic. So let's say we are having the first question. These questions are from probability, not from AP. Okay. So the first question is a standard. Everyone can see my screen, right?
Yes, ma'am.
Okay, let's continue. A standard six-sided die is rolled. What is the probability of rolling an odd number or a number greater than 3? Whenever we are having this word no and or in a probability question, we need to know this or. This or means addition, okay? And whenever we are having and, like probability of A and B will be probability of A multiplied with probability of B. If we are having or, we will be adding the probabilities, and if we are having and, we will be doing the multiplication of the probability. So according to these concept, we have to proceed over here. Let's see, a standard six-sided die is rolled, so the outcome can be 1, 2, 3, 4, 5 or 6. What is the probability of rolling an odd number? So from here, if we will focus on odd number, I can see 1, 3 and 5. These three are odd number, and if it would ask just to find the probability of odd number, getting an odd number, it will be probability of getting odd will be 3 by 6, right? Now here one more part is added over here, which says or a number greater than 3. So or is there, and now only I'm telling you or means we have to do the addition. But what are the numbers which are greater than 3 over here? So if we will focus on the numbers which are greater than 3, so I can see 4 is there. I can see 4 is there, 5 is there, and 6 is there. So again we need to take this 5. No, whenever there is a common number like this, then we are not going to take it in both the cases. We will be taking only 4 and 6. Okay. So for the second case, probability of a number which is greater than 3, we will be considering 4 and 6. Why not 5? Because as you can see, 5 is also having underline. That means that we have included in the first probability. So let me write it, probability of getting an odd or number greater than 3, it will be odd number, that is 3 by 6, plus greater than 3, as I told you that 5 we have already considered for the first case, so we can't take that, so we'll be taking 2 by 6. Yeah, this is how, just by adding both of them, we will be getting the probability. Is it getting clear? Is it clear to everybody?
Yes, ma'am.
Let's move to the next question. So there is a assertion and reasoning based question. It says in a standard deck of 52 playing card, 52 playing cards are there. The probability of drawing a red card, probability of drawing a red card and a face card and a face card is 1 by 3. Let's check it whether it's 1 by 3 or not, because this is the assertion given. If that is 1 by 3, we can say that yes, the assertion is correct. So here, if you will focus on the word and is there, and now only we were discussing about or and I said to you or means addition and means multiplication. So probability of drawing a red card and a face card. So how many red cards are there? Total 52 playing cards are there. Out of this, how many red cards are there?
6.
Yeah, what?
Ma'am, 6.
6?
6 red cards.
Only 6 red cards are there?
Ma'am, or 12.
Okay, let's check how many red cards are there. Okay, for that you need to look at the structure of the card, then only it will make sense. If here I will list down everything regarding the card, then you will just we will be solving the problem, then you will forget about the cards. So the best way to understand the structure of the card is to have the card, look at the card, or if you are having at your home, you can see the card, or I'll be showing you the card. So I am not having physically the card, but I'm showing you. Just give me a second. Can you see my screen?
Yes,
Eh,
ma'am.
Just a moment. Let me zoom it. So these are the structure of card. Here we are having. Let me check the better one. Which is the better one? Yeah, this is the. So club is there, spade is there, heart is there, diamond is there. Heart and diamond both are having 13 cards. Can you see? So total 26 red cards are there and total 26 black cards are there. Can you see it?
Yes, ma'am.
And if you will look at the structure previously which I have taken over here, in that you will also be able to see that half of them are red, half of them are black. So if I am having 4 ace, that means 2 are red, 2 are black, right?
Yes, ma'am.
If I'm talking about the face card, so 4, like each are jack is 4, queen is 4, king is 4. So 4 cards are there. That is the face card. Okay. Now among this those face card, let's come to the screen, the original screen. So among the face card, or every card is having 4 type. two black, two red. Among two black, one is like one is from each category. If we are having four cards, so one is diamond, one is club, one is a spade, and one is what's that? A spade is there, heart. So if spade is there, diamond is there, heart is there, and club is there. So each one is having one card. So if I am talking about 10 card which is having 10 on it, so each one is having 1 10 from here, 1 10 from here, 1 10 from here, and 1 10 from here. This is how the cards are arranged. So here it says that probability of drawing a red card and a face card. So how many red cards are there? 26 red cards are there out of 52 cards. Yes or no?
Yes, ma'am.
Okay. Now we are also drawing a face card. So how many face cards are there? Four face card means Jack, Queen, and King. So how many face cards are there?
12.
Yeah, 12 cards are there. Just a second. So total 12 face cards are there. And how many total cards are there? 52. Okay. So probability of getting a red card, and means here we can see and means multiplication. A face card, that means 12 by 52. We have to take both the cases and we have to do the multiplication over there. Okay.
Yes.
Let me check one thing over here, which is very important for this topic. Okay, so here it says that probability of drawing a red card and a face card. When we are counting the red card, already we have considered few face cards. Yes or no?
Yes, ma'am.
So as we know, half of the cards are red cards, half of the cards are black cards. So among these face cards, that is 12, 4 from each, 4 from this one, 4 from this one, and 4 from this one. I can say 2 red, 2 black. 2 red, 2 black. Here also I can say 2 red, 2 black. Right?
Yes, ma'am.
So the red, which we have already considered, we are not going to take it one more time. What we are going to do, we will be taking only the black cards which are face card. Okay. So this one plus 6 are from 12, half of the cards are red card, half of the cards are black card. So red already we have assumed, black we are going to take over here, that is 6 over, just a second. Okay. So yeah, 6 out of total card, that is 52, not 12. So that's how we'll be taking each and every cases carefully. So let's get back to the question. Here it says that probability of drawing a red card. Out of 52 card, half of the cards are red, half is black. We have taken probability of getting red card, that is favorable outcome 26, total outcome 52. And a face card. How many face cards are there? 12. Out of that, we have already assumed the red card. Okay. So we can't take that. We are taking the black card only, divided by total number of card again. And this is how we will be getting the total probability. And accordingly, we will check whether the assertion is correct or not. Is it clear to everyone?
Yes, ma'am. Clear.
Okay. Let's move to the next part where the question says, when we are rolling, when we are rolling, it's written you are rolling two six-sided dice that the sum of the number is 7. This type of question we have already discussed in class, that the sum of the number is 7. That day we were doing the table, and that day only we have discussed when the sum is 5, when the sum is 6, how to take the cases. So when the sum is 7, the possibility will be the first one is having 1 and next one is having 6. Then and only then the sum will be 7. Here we are listing down all the favorable outcome. If the first one is 2, then the next one has to be 5. Then and only then the sum will be 7. If the first one is 4, then the next one has to be 3. Then and only then the sum will be 7. If the first one is 4, then the sum will be 7. And if the first one is 4, next has to be 3. Then and only then the sum will be 7. The first one is 5, next one will be 2. Then and only then the sum will be 7. And if the first one is 6, the next one will be 1. Then and only then the sum will be 7. This one is the favorable outcome. Number of favorable outcome we'll be taking from here, and whenever we are throwing two dice, that time the total number of outcome has to be 36, that is 6 square. So the probability we can get from here, 1 2 3 4 5 6, the favorable outcome divided by 36, the total outcome. Okay, is it okay?
Yes, ma'am.
This one we have already discussed during the class. Now the next question is the probability that a non-leap year selected at random, the probability that a non-leap year selected at random contains 53 Sundays. So non-leap year is having total 365 days. Okay, as we know in a year 365 days are there. That's for non-leap year. This 365 days, if we will just segregate it in terms of weeks, then we need to check how many weeks are there. So if we will be dividing 365 by 7, 35, so we can say total 52 weeks are there. Can you see over here? Total 52 weeks are there, and one is the remainder. That means one extra day is there. Total 52 weeks are there. In this 365 days, total completely 52 weeks are there, and one extra day is there. Okay, this is how we can do the multiplication. If you will do 52 into 7, you will be getting 364. Okay, so total 52 weeks are there, which will give us 52 Sundays. Now, if we want one more Sunday, probability that a non-leap year selected at random contain 53 Sunday, then that one extra day has that extra day can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? What is the favorable, which one is the favorable day? It's Sunday. So that one extra day can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday. These are the total, like these are the total number of days. Like these are the now name of the days which can be that extra day. But what we need Sunday. So we can say out of 7 we need one. In this particular case, the favorable case is only Sunday. So we want Sunday out of these days. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. In between these days, I want Sunday. If that is the case, then we will be having 53 Sundays. Yes or no?
Yes, ma'am.
So getting 53 Sundays has to be 1 by 7, because already we are having in hand 52 Sunday. One more Sunday if I want, then that probability 52 is sure and certain. That's why we are not thinking about that. That is sure case. One more Sunday if we need, that's probability is 1 by 7. The way it's just like the way that when we are throwing a die, the outcome is 1, 2, 3, 4, 5, 6. Now the probability of getting 2 is 1 by 6. The probability of getting 6 is 1 by 6. Similarly, the outcome can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, Saturday. Out of this, what we need? Sunday. That means 1 by 7 probability will be there. That's it. Okay. Next one is a coin is tossed 3 times. List the possible outcome. A coin is tossed 3 times.
Ma'am, we did this question.
List. Can you see
Ma'am,
now?
we did this question, ma'am.
Yeah, I did this question. When the coin is tossed 3 times, list the possible outcome. Find the probability of getting at least 2 head. So when it says find the probability of getting probability of getting at least 2 heads, whenever I am saying no, like whenever you are saying you need at least 2 chocolate, that means bare minimum you need 2. If I'll give 2, you will accept it. If I'll give 3, you will accept it. If I'll give 4, you will accept it. But if I'll give 1, you will not accept it. So at least something means like you can take that amount or more than that. So here if it says find the probability of getting at least 2 head, that means minimum 2 head wherever is there, that is our favorable case. But if more than 2 head is there, that also is our favorable case. Okay? Is it
Okay,
okay?
ma'am.
So whenever it's asking about the find the probability of getting at least, suppose we are having head. Suppose you are having tail head. Suppose you are having tail. Suppose you are having head. Okay. like this, a lot of different possibilities you are having, you know how to list it down. If one head is there and two head, that means minimum two head is required. Less than that is not acceptable. If one head is there and two tails are there, that is not acceptable. This one is acceptable. At least two head is acceptable. And if more than two heads, all are head, three heads are there, that is also well and good. So how many favorable are there according to this one? I can say three. But you need to list down all the possible number of sample space. First you need to list it down when we are tossing a coin three times. Okay, accordingly you will check how many times it's the favorable case where you are having at least bare minimum two or more than two. Okay, will you be able to do that?
Yes, ma'am.
Okay, let's continue with the arithmetic progression. Just a moment, Lord. Let me open the book first. Let's start. Now, as you know, whenever we are talking about this arithmetic progression, it's all about the sequence, it's all about the pattern. Okay. And whenever we are having a certain pattern where the difference between each and every data is same, whenever we are having a very basic sequence and series based question, if you have given the Olympiad, if you have given the quizzes from the very beginning, like from the very smaller classes, then you must have done this type of sequence, that 2, 4, 6, 8, then what will be the next number. So you have I believe you are aware with this type of sequences, even if when arithmetic progression the term was not known to you, right? So there what we used to do, we used to see the gaps. The very first thing for solving any sequence or pattern or series is to see what's the gap between these two. So the gap between these two is 2, the gap between this two is 2, the gap between this two is 2. Then the next one will be again the gap will be 2 only, and the next one will be 10. So this is how we used to take out the number. This is the very simple example I have given, but there are quite bigger number used to be there where we used to check the differences, and most of the time the difference between the consecutive numbers used to be same. That is the most common pattern, right? So in class 10 you got to know that okay, this is called arithmetic progression. Here the sequence is progressing in like a well structured manner, that is there is a common difference between co- two consecutive terms. So now these are called terms: first term, second term, third term, fourth term, fifth term, nth term, last term. So this is how the terminologies came, and the common difference also came out. So what exactly is the common difference? So when we are having 4 minus 2 is 2, or 6 minus 4, common difference. If you will focus on the name only, the name is saying common difference. There is a common difference between each consecutive pair. That's called common difference. Okay. So here the first exercise, if we will pick, and we will pick few questions from there. Let's start with the question itself, because I believe the base, the introduction, this part is clear to everyone, right? Right?
Yes, ma'am.
Okay. So let's start with the question itself, where we will be dealing with the nth term, number of terms and all. Okay, so first exercise is very simple. Let's do it and then we'll be moving quickly to the next exercise. So here it says, let me write it. The taxi fare, this type of question you can expect in MCQ type of question. So if you understand the meaning very well, then and only then you will be able to answer this type of question which are related to arithmetic progression. So it says the taxi fare after each yeah, let's continue. So I was writing that the taxi fare after each kilometer when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So is it in arithmetic progression or not? That's what we have to answer over here. And if it is in arithmetic progression, then why it's in arithmetic progression? Okay, the reason also we have to give. So if we will go through the given statement, it says that taxi fare after each kilometer when the fare is rupees 15 for the first kilometer. So for the first kilometer, the fare is rupees 15. Okay. Now rupees 8 for each additional kilometer. So if we are going for the next second kilometer, the like one more kilometer if we'll go, for 2 kilometer if we'll go, and then the fare will be 15 plus 8 because it is increasing by 8 for each additional kilometer. For the next one, so 15 plus 8 is 23. It became 23 rupees. Now again for the next kilometer, that is for 3 kilometer, the fare will be 23 plus 8, right? That is 31 rupees. So we are getting the pattern like this: rupees 15, then 23, then 31, and each time we are adding a same number, that is 8 8. So no need to analyze here, only we can say it's in arithmetic progression, right? Yes or no?
Yes, ma'am.
Difference between 15 and 23 is 8. The common difference between 23 and 31 is 8. So obviously it's in arithmetic progression, right? So
Yes.
we can say it's in arithmetic progression. And why it's in arithmetic progression? Because we are having a common difference of 8. That's why it's in arithmetic progression. Let's do quickly the next one and the very next one. I'm not going to write it. I'm just dictating it. The amount of air present in a cylinder when a vacuum pump remove one fourth of the air remaining in the cylinder at a time. Okay. So amount of air present in a cylinder. So let's say at first a this much air is there. Okay. Then one it says the amount of air present in the cylinder when a vacuum pump remove one fourth of the air remaining at a time. So if we will pump it, it will just exclude one fourth of the air at a time. So A from A it will exclude 1 by 4A. The next time, what is the remaining? 3A by 4. If we will again pump it, it will again remove one fourth of the remaining. So what's the remaining? Remaining is this one. So 3A by 4 is already there. From here, one fourth of the remaining, it's excluding. Let me check whether better if we will be taking any number that will make it more convenient, or with A only we can proceed, or whether like you will be able to understand. So let me take a number and let me check whether we can go ahead with a number. I believe a very bigger number like 100,000, that will be divisible by 4, and we can take those number. Let me check it on pen and paper first. So if we are having, let's say, let's start with the bigger number. Let's say we are having 1000, this much centimeter cube, this much this is the volume of the air at first. Okay, now here one fourth is, one time we will pump, and one fourth of the air will just we will lose it. So if we are pumping it one time from 1000, one fourth of 1000 will go. That means 1000 minus 250. That means 750, right? Yeah. So we are having first number as a 1000. We ended up getting the second number as a 750. Now what about the third number? The third number, whatever is there, from there, one fourth of the remaining only will we will lose the air from the cylindrical tank. So let's see whether it is cancelable or not. 187.5. So 750 minus 187.5. If we will do the subtraction, we will be getting a decimal number. You don't have to do this much of calculation. Just for your understanding, I am showing you by taking a number. Otherwise, we were good with a 3a by 4 and then 3a by 4 into this one. That time also we needed to do few calculation. I am just making it more clear with the calculation, with the number. So 750 minus 187. 0.5. If we will be taking, we will be getting 562.5. If you will look at this pattern, is it in AP? Is this in AP? Can you see?
No, ma'am, it's not in April.
Not at all in AP. We don't even have to do the subtraction because we know the gap between these two is 250, but the gap between these two is obviously not 250. So it's not in AP. Okay. So the second question, whatever it says, even if you will be doing with A, you will be doing with V, or if you want, you can do with number, whatever seems comfortable to you. This is how we will be getting it, and definitely it's not in AP. Now the next one says the cost of digging a well after every meter of digging, when it cost 150 rupees for the first meter and rises by rupees 50 for each subsequent meter. So for the first meter the cost of digging is 150 rupees. For the first meter the cost of digging is 150 rupees. Okay, and then again and again it is rising by 50 rupees. So one, if we are going to second round, if we are digging it more, it is 150 plus 50. Then again we are digging it more, so this has become 200, 200 plus 50. So here we can see it's in AP, right?
Yes, ma'am.
So this is in AP. The amount of money in the next one, okay. The next question says the amount of money in account every year when 1,000 rupees is deposited at compound interest at 8% per annum. We know that there is a difference between simple interest and compound interest. In simple interest, we have to give same interest each and every year. But in compound interest, it's just get compounded. Okay, compounded means it will just keep on increasing. If you have learned the concept of compound interest very well, then you know that for the first year it will be just like simple interest, for the second year it will be more than simple interest. So let me show you, if you don't know, a very simple case. Compound interest, here the rate is 5% and here also the rate is 5%. Okay. Now simple interest means, suppose we are having principal as a 1,000 rupees. So for 1 year it will be P into R into T by 100. That is the interest formula, and that gives 1,000 into 5 into 1 year by 100. That means 50 rupees. Okay. If you will be finding for 2 years, the interest will be again P into R into T by 100, and here you need to take 1,000 into R is 5 into 2 years divided by 100. Can you see we are getting 100 over here? Here we have got 50. Can you see?
Yes, ma'am.
50 in the first year, 100 if you are giving directly in the second year, that is 100. So 100 means 50 for the first year and 50 for the second year. This is how simple interest will keep on going. If you will be directly going and paying in after 3 year, it will be 150. Okay, if you will be going directly in the bank and you are going to pay the simple interest after 4 year, it will be 200 rupees. So for every year they will be just charging 50 rupees, 50 rupees, 50 rupees, 50 rupees, like that. That is called simple interest. But what about compound interest? It will just keep on getting compounding. So if rate is 5%, if principal is again same 1,000 rupees, and if we have to find the compound interest, for the first year it will be just like the simple interest, that is 50 rupees. Okay, you can calculate it by the with the help of compound interest formula also. That amount will be equals to P1 plus R by 100 to the power n. By this formula, P is 1,000. If you will be calculating it 5 by 100 and 1 means for 1 year, you will be getting the same thing just like the principal, just like the simple interest, that is rupees 50 over here. Okay, you will not be getting 50 because this is the amount, so you will be getting 1,050. 1050 you will be getting, and that is the amount, that means 50 extra they are charging to you. Now when you will be going for the second year, then what they will do, they will charge the interest on this amount. On this amount they are going to charge the interest 1050, this much 5% you have to pay to them. So that will be different from 1050's 5% means 52.5. Can you see next year they are charging you 52.5? First year they have charged you 50 rupees just like the simple interest case. But next year they are charging you 52.5. Why? Because now they are not considering that the principal is 1000 rupees. They are thinking that the principal is 1050. So on the bigger principal, if they are charging 5%, the amount will come out as a bigger value. Yes or no?
Yes.
Now in the third year, if you will go, what the bank will feel that now you are not having 1000 rupees or 1050 rupees. You are having the principal now as 1050 plus 52.50 or 5. This much principal you are having. On this principal, they are going to charge you 5%. Okay, so you need to understand 100 rupees 5% and 200 rupees 5% or 1000 rupees 5%. Every time if you will be finding the 5% of each and every one, it will come out as a 5. This will come out as a 10. This will come out as a 50. So if a bigger value 5% you will be counting, you will be getting a bigger number, and that's where they are playing with, like they are making the, like obviously they are doing the business. So this is how they are doing the business. Every time they are increasing the principal now in each and every sector. If you will ask your parents, if they the money they have deposited in bank, the money if they have taken loan from the bank for any purpose, so everywhere the banks and everything is charging us compound interest, not the simple interest, and that's how they are making more and more money. Okay,
Okay.
so if we are having compound interest case, the amount of money in the account every year when 1000 is deposited at first, and compound interest is 8%. So just by looking at this word compound interest, we know the interest each and every year will not be same, and that will not be in AP. Okay, can we move ahead? Anyone
Yes.
want to ask anything from here?
No, ma'am, understood.
Now the next question says write first whole term of AP when the first term A and the common difference D is given. Okay, this one is also very simple. I will be doing one of them and leaving the rest to you. So if A is given as a 10 and D is given as a 10, then first term is A, that is 10. Next term is A plus D. That means A plus D is the next term, and that is 10 plus 10 is the next term, that is 20. After that, the third term is, there is a sequence that AP always, the standard sequence or the standard pattern of the AP is always like A plus D, A plus 2D, A plus 3D. This is how our AP looks like. Why this is our AP looks like this? Because we know that A plus D. Now in this A plus D, in this A plus D, we are adding the common difference D again, which is making it A plus 2D. Okay. Now in this A plus 2D, the previous term, we are adding common difference D again, which is making it A plus 3D. That's why the standard form or the general form of AP is this one. A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D. Okay, like this the pattern will be going. So if we have to write the sequence with the help of A and D, clearly, like easily we can write it with this pattern. With the help of this pattern, A plus D, A plus 2D, A plus 3D, we can make the arithmetic sequence. Okay, clear?
Yes, ma'am.
Next one is for the following AP, write the first term and the common difference. Okay, this one is also very simple. If the AP is already given, if I am saying the AP is 1 by 3, 5 by 3, 9 by 3, 13 by 3, dot dot dot. Here first term A is 1 by 3. Common difference D is this one minus this one. Or we can also find it by using the other two consecutive term. Any two consecutive term we can take. So I can also take this one and this one, and we can say the common difference is 9 by 3 minus 5 by 3. So either do like this or do like this, or you can also do 13 by 3 minus 9 by 3. Every time you must be getting the same thing. So by taking any two consecutive term you can show the difference. Okay, and that is the common difference. So here we'll be getting 4 by 3, that is the common difference. If you are finding from here also you can check 4 by 3 is the common difference, because already in the instruction it is mentioned that the given sequence is in arithmetic progression. So we don't even have to check it. All the common difference will be same. Are you getting it?
Yes, ma'am.
Now the next number 4 says which of the following are AP? If they form an AP, find the common difference D. Now we have to check it, whether the given sequences are in AP or not. Let's check few of them, the which I feel is quite tricky. Let's do that and let's move to the next exercise. So if we are having 3 plus root 2, next one is 3 plus 2 root 2, next one is 3 plus 3 root 2. Let's check whether this one is in AP or not. So the common difference has to be same. Common difference, if we will start finding, so this term minus this term, let's check it. 3 plus root 2 minus 3 will be only root 2. Let's check for the next two terms, this one and this one. Okay, so 3 plus 2 root 2 minus 3 plus root 2 in bracket obviously. Okay, please be careful and use the brackets. Most of the time student leave this bracket and try doing step jump. Please don't do that. Okay, there you will do end up doing mistake with the sign. So here we are having 3 plus 2 root 2 minus 3 minus root 2. 3 gone. 2 root 2 minus root 2 is only root 2. Yes or no? Do you know this calculation? Whenever we are having 2 root 2 minus only root 2, that means we can assume it like 2x minus x. That is only x, right?
Yes.
And basically from where this concept came out? This concept came out that we are taking root 2 common and we are doing 2 minus 1. We are taking root 2 common, 2 minus 1 is 1. So basically it became 1 into root 2 or 1 root 2 or only root 2. Getting?
Yes.
Is it clear to everyone? Is it clear?
Yes, ma'am. It's fine.
Okay. सो 2√2 में से √2 जब भी माइनस करेंगे, √2 को लाइक टर्म कंसिडर करके माइनस कर सकते हैं। जब भी हमारे पास 3√5 होगा प्लस 4√5 होगा, तो √5 को लाइक टर्म्स कंसिडर करके 3 + 4 को ऐड कर सकते हैं, एंड दैट विल बी 4, 5, 6, 7√5 आंसर होगा। Okay, and again, if it is not clear over here, then you can take out √5 common, and then you can add 3 and 4. So eventually you will add at same value. So I can see the common difference is same. Here is √2, here is √2. Let me check more terms are given over there. No. So yeah, yes, one more term is there. Let's check them. So difference between this one and this one. Here only we can say the answer will be √2. Difference between 3 + 3√2 minus 3 minus 2